Hi there, it's Albert Luck again from luckymaths.co.uk. This is the work solutions for paper 2A, non-calculator. So first page, the first 5 there, just left them as they are with the solutions from before. On the pictogram question, just used possible ratio table there for the 3 times 15 for part B. How many students attended the club on the Friday the following week is 3 times more, 115, 2 double it, 2 15s, 3 15s that way. But question 7 is where I've got a ratio table in the bar model potentially to see that one. Of course, it relies on the fact of 4 kilograms is equal to 4,000 grams. But 1 box is 720, 2 boxes 1,440, 4 boxes weigh 2,880 grams. Now in the bar model there, I've tried to show that if obviously we've got 4,000 to play with in total, so to show why if you take obviously 2,880 away, you're left with 1,120. Algebra-like terms, we've got 6p and another 2p in the first box to show that is 8p in total. On the right there, we've got 3q and minus q. So as I've said before in previous videos, q minus q, 1q take away 1q is 0. So that's why in that box, all that remains is a positive 2q. Expanding brackets, I've talked about 4 lots of 2b plus 3 is set out in full on the first box on the left. 2 lots of b minus 5 is in the, obviously the bit on the right. If we look at all the letter b's together, 2b plus 2b, 4b, 6b, 8b, and then another 2 makes 10b in total. With the numbers, we've got 3, 6, 9, 12 on the left. Take away 5 is 7, take another 5, it leaves us with positive 2. Lowest common multiple, first students to just probably write out 2 lists here. Take your time and find the first number that's in both, 1,080. Venn diagrams is of course a good alternative method, just requires a little bit more understanding, I would say. This kind of money currency kind of question, 3 t-shirts I've worked out there, $75. I put the 60, the trainers, and the 75 and the 80 together into a bar model to basically show that is $215, which of course is more than the 200 he's got to spend. 54 lots of 28, 315 divided by 5, both done using a ratio table here. On the top, we're doubling 1 lot, 2 lots, got 4 lots there. And then 10 lots and 40 lots is where the 50 lots comes from. So 54 lots is 1,120 for me, plus 280 plus 112, 1,512. And to do 315 divided by 5, I'm counting up in fives. 1 5, 2 5s are 10, etc. But with those facts, if we use 25s, it's 100, and 45s is 200 together, we can see the bottom numbers add up to 315. I've underlined. So if we add up the circular numbers in terms of what I've circled, that means 63 lots of 5 would be 315. Probability tree. Understanding it adds up to 1 is obviously key here. 0.6 leaves 0.4, 0.8 to 0.2, and 0.3 to 0.7. Just nice 2 marks if you can again use that, addition, subtraction to 1 rule here. Be careful with part B that we are multiplying. If it's apple juice to pass, 0.6 times 0.8, the mistake there, a lot of students will add those decimals. And finally, we've got a situation with, again, a few bar models being used to help with this worded question. Dance club has 80 members, half are adults. So first bar model shows clearly 40 are adults. We are told adults is 4 times the number of teenagers. So I've got 4 boxes for adults compared to 1 box for teenagers. 40 adults into 4 boxes or 4 parts is 10 per box. And that means there were 10 teenagers. And then the last bar model there, 40 adults plus the 10 teenagers, leaves us with 30 children, as we can see. And then it's a ratio of children to teenagers. And I've used the ratio table to show 30 to 10 is basically a ratio of 3 to 1. And so the value of n, therefore, is going to be 3. Basically, what it's saying, for every 1 teenager, there are 3 children, to look at it like that. 3 children to every 1 teenager. Hope that's been useful, and thanks for watching.